A. Divya, Assistant Professor, Department of Computer Science, Self, V. Vaniya Perumal College for Women. In this video, we are going to see about 1's complement and 2's complement in the R's complement system. So first we see what is R's complement. In binary system, we have to represent the signed numbers either by using 1's complement or in 2's complement form. First we see what is 1's complement. So we have to find 1's complement of a number by two methods. In the first method, we have to replace each 1 by 0 and zeros by 1. In the second method, we have to subtract each binary bit by 1. First we see the example for the first method by replacing all zeros by 1 and ones by zeros. So in this example, we have to find the 1's complement of 1, 0, 0, 1, 1, 0. So the given number is 1, 0, 0, 1, 1, 0. So starting from the right position, the value is 0. So it is converted to 1. So the previous bit is 1. So it is converted to 0. And the next previous position is bit is 1. It is converted to 0. And the previous value is 0. It is also converted to 1. And the next bit is converted to 1 and the first bit is converted to 0. So the 1's complement of a number is 0, 1, 1, 0, 0, 1. Before we have to see about the second method, we have to know about the subtraction rules. The rule is 0 minus 0 is 0. 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 1 is 1. So this is an example for the second method, that is we have to subtract each bit from 1. So we have to find the 1's complement of 1, 0, 0, 1, 1, 0. So subtract each bit from 1. So starting from the right position, 0 minus 1 is 1, 1 minus 1 is 0, 1 minus 1 is also 0, previous bit 0 minus 1 is 1, 0 minus 1 is 1, 1 minus 1 is 0. So use 1's complement using subtraction, we get the result as 0, 1, 1, 0, 0, 1. The same result we get from the first method. Next one is we have to find the subtraction by using 1's complement form. So in this, first we have to take 1's complement of the subtrahend and add this value to the minuend. If there is a carry is generated, it indicates that the answer is positive. So we have to carry to the result. So that carry is called end around carry. If there is no carry is generated, then the answer is negative. So we have to take 1's complement of the original value and change the sign. So this is an example for subtraction using 1's complement. We have to subtract 1, 0, 1, 1 from 1, 1, 1, 0. In this, the subtrahend is 1, 0, 1, 1 and the minuend is 1, 1, 1, 0. So, we have to take 1's complement of the number, that is, we have to replace zeros by 1 and ones by 0. So, we get the answer as 1's complement of subtrahend as 0, 1, 0, 0. Before we are going to move to next step, we have to see some addition rules. So 0 plus 0 equal to 0. 1 plus 0 equal to 1. 1 plus 1 equal to 1 0. 0 plus 1 equal to 1. 1 0 plus 1 equal to 1 1. So add the miniand to the 1's complement value. So the miniand is 1 1 1 0. The 1's complement value is 0 1 0 0. So first starting from the right bit, 0 plus 0 is 0. There is no borrow. So move on to the previous bit. 1 plus 0 is 1. Move on to the previous bit. 1 plus 1 is 1 0. The carry is generated. It is move on to the previous bit. So 1 1 1 plus 1, we get the answer as 1 0. In this, carry is generated. If carry is generated, we have to add this carry to the result. So move the carry to this position and add the value. So we get the answer is starting from the right position, 0 plus 1 is 1. The remaining bits are same. So 0 0 1 1. So the final answer is 0 0 1 1. Next value is 2's complement. First we have to find first complement of a binary number, then add 1 to it. So this is an example for 2's complement. To find 2's complement, we have to find 1's complement first. That is by replacing each zeros by 1 and 1's by zeros. So the 1's complement of a number is 0 1 1 0 0 1. The original bit is 1 0 0 1 1 0. Next we have to add 1 to it. We get the answer starting from the right position. 1 plus 1 is 1 0. Borrow is carried to the previous bit. So 1, that value is added to the previous bit. So 1 plus 0 equal to 1. The remaining bits are same. So we get the 2's complement value as 0 1 1 0 1 0. Next, subtraction using 2's complement form. So first in order to find 2's complement of a subtraction using 2's complement, we have to take 2's complement of the subtrahend and add the miniand to it. If there is a carry, it indicates that the answer is positive, so omit that carry. If no carry is generated, then the answer is negative. We have to find the 2's complement of the original addition and change that sign. So this is an example for subtraction using 2's complement. We have to subtract 1 0 1 1 from 1 1 1 0. Here the subtrahend is 1 0 1 1 and the miniand is 1 1 1 0. So we have to find 2's complement of subtrahend. The value is 1 0 1 1. First we have to find 1's complement by replacing all zeros by 1 and 1's by 0. So we get the 1's complement value as 0 1 0 0. Next we have to add 1 to it. So we get the result as 0 1 0 1. Next add the 2's complement value to the miniand. The miniand value is 1 1 1 0 and the 2's complement is 0 1 0 1. So starting from the right bit, 0 plus 1 is 0, 1 plus 0 is 1, 1 plus 1 is 1 0. Borrow is generated. That borrow is carried on to the previous bit position. So in this, so the borrow is added to the previous bit, 1 plus 1. So we get 1 0. In this, carry is generated. if carry is generated, we have to ignore that. So the result is 0, 0, 1, 0. So there's a final subtraction using 2's complement value is 0, 0, 1, 0. Thank you.